moved to the US and to DC basically 3 years ago, and before that I was in Europe. And I'm originally Italian. I worked but then after studying in Italy I worked in France and then in Switzerland, and now I'm here. I work at Georgetown University in the physics department. So I do statistical physics and computational physics. So I do a lot of my group, we do a lot of computer simulations, a bit of theory. Our specialty is to work on materials. So what I'm interested in actually and what we work on are materials that are actually relatively familiar, like plastics or beauty products like shampoos or creams, and in fact also cement. Their structure is very complicated. Their properties come from the organization of the atoms, molecules or aggregates, which in fact it's incredibly complex to rationalize, to describe. So this is my bag, so it's nearly a suitcase, I would say. That's why I like it. And of course there is the computer. Things that are apart from obvious things that everybody would carry, I do things like I carry like a notebook because I like to take notes on paper. So one thing that I carry, and maybe this is a bit strange or I don't know if it's so nice, but in fact what I carry is this, that it's unrelated to whatever work thing, is this, which is a screw, which I actually had in my leg for some time because I broke a leg skiing and I fixed it with a screw, and then they gave me the screw when they took it out, so I just keep it, and it's some sort of charm object that I have with me. So my wow finding, it's probably one about cement. So the issue why we were interested in cement, we're still interested now, is because in fact the way the cement is produced nowadays is responsible for something like 5 to 8% of the whole man-made CO2. It's a process that it has a huge carbon footprint. And so how to reduce this environmental impact is by changing the material properties. But because we don't understand exactly where those material properties come from, then it's incredibly hard to understand how you can actually make this process better. Within, let's say, 3-4 years, we really started to have the proof that the model that we were studying had really some connection with the experiments that were being done, and then we were able to develop new ideas actually to change the material properties, so where to act to change the material properties. Ciao ragazzi, fare scienza è fantastico e bisognerebbe provare, sempre.